So this is Roshni Lulla. She's a PhD candidate at USC. We've worked together for several years now. She's brilliant, and is interested in kind of the mirror image of a lot of what I and other people have studied, which is like, why are things altruistic? And she's very interested in the opposite, like what are the roots of antisociality? And so she'll be talking about that as part of a rehearsal for her oral qualifier.
Yeah,
Qualifying
all
exams.
oral qualifying.
So let's pretend we're hard-nosed
Yes.
senior academics.
Yeah.
Yes.
Please tell me if things don't make sense, or if I can like clarify stuff on the slide,
Sure.
or it's all complete nonsense.
Bring out my inner Matthew.
Yes. Or you're inner DiMaggio.
Later tomorrow. Yeah, actually even better.
That's even
Yeah,
better. He's on my committee, so
I'll
we
bring out
can
the
ask those hard questions.
What do you mean?
Yeah, exactly. I had my first meeting with him. It was very interesting.
Was it cool? Yeah.
Yeah, he didn't know what ChatGPT really was, and so we downloaded on his we downloaded on his iPad, and he gave it like this British voice, like a very strong feminine British voice. The first questions he asked it, he goes, "What do you know about this guy Antonio Damasio?" I was like, "You're just asking the thing about yourself."
I love that.
It was so funny.
We must protect him at all costs.
Yeah, he's so funny.
Yeah.
Okay, cool. So as Leo said, my name is Roshni. I am a fourth year PhD student, soon to be candidate on Friday. In Brain Cognitive Sciences, I work with Antonio Damasio and Jonas, and I worked with Leo for a while at the BCI. And I'm going to be talking about the Dark Triad. So movies have shown AI becoming too powerful and causing harmful outcomes fictionally for years. And although these are exaggerated examples, these fictional displays relate to my research at USC. Specifically, I study antisocial behavior via the Dark Triad and explore how we can apply this work to the development of safe and ethical artificial intelligence. So I will talk a little bit about my previous work, talk about the Dark Triad a bit, and then my aims for my dissertation are split into three, which is neuroscience, behavior, and then artificial intelligence. So my previous work focused on the neural basis of empathy. Specifically, I was using neuroimaging paired with multivariate analyses to look at how affective stimuli is represented in our brain and how those representations in our brain relate to empathic abilities. My master's looked at the representation of both valence and arousal across affective stimuli and how that related to empathy. And we found that the representation of arousal specifically in more sensory integration areas related to the ability to take the heightened ability to take the perspective of others. And then my most recent paper, which is my first author paper that was done with a lot of people here, was looking at similarly representations of affective stimuli in the brain, but looking at dissimilarity across those patterns and how that related to empathic abilities. And now my work is kind of pivoting to the flip side of this, which is the lack of empathy that we see in antisocial behaviors. So I'm looking at the Dark Triad. This was introduced in 2002, so it's a relatively new topic of research. While people have looked at behaviorals associated with the Dark Triad and the traits of the Dark Triad individually, they haven't really looked at neuroscience findings in relation to the Dark Triad, and I'll talk about what the Dark Triad actually is in a second. But basically, this is an area of research that has a lot of potential. So the Dark Triad looks at these three traits of Machiavellianism, narcissism, and psychopathy. And while some of these traits like narcissism, psychopathy can be studied in a clinical sense, like narcissistic personality disorder, antisocial personality disorder, the Dark Triad specifically looks at these in a subclinical level, so how they kind of vary in a normal population. So these traits are kind of present in the people all around us, and they may even be present in like a lot of our leaders. A lot of leaders show narcissistic traits. Some people maybe more than others. But the point of the Dark Triad is not to give a clinical diagnosis, it's just kind of evaluating these traits in a normal population. So Machiavellianism is based off of Machiavelli, the Italian dictator, and it relates to a sense of manipulation, lack of affect, and kind of idealistic goals.
Quick thing Antonio might say, not a dictator. He was a teacher to the Borgias, right?
He was a statesman and
philosopher. He was a statesman and philosopher.
So he was not technically a dictator?
No, he was a philosopher. Yeah, he was a philosopher. In fact, his writing, The Prince, which is coined, was actually kind of low-key, possibly a covert warning, essentially spreading to the general populace an understanding of how the powerful employ, how the powerful employ power.
Okay, cool.
So yeah. So kind of the opposite.
Okay, and then narcissism, again, this can be studied in a clinical sense, but people are sure familiar with this. It's a sense of grandiosity, self-admiration. It is theorized that it influenced Freud's idea of the ego and superego. And then psychopathy is the most thoroughly studied across the traits. It's very commonly studied as antisocial personality disorder, but in this sense, it relates to antisocial behaviors and abnormal emotion processing, a lot of like affective dysfunctions, and a lack of like affective reactivity. So these traits are interconnected, but they generally represent these distinct profiles that have some things in relation to each other. And there's been a lot of work connecting these traits together, which is why they can be studied as the dark triad. But there's certain things that are shared, like impaired affect, high levels of risk-taking, and a sense of moral dysfunction, where they place low value on moral foundations. And I'll talk about the traits and behaviors a little bit more in a second. But as I mentioned before, there is this risk of AI that we've seen in fictional ways of AI turning antisocial and gaining too much power. And my motivation behind studying antisocial behavior across the brain and through behavior is to explore how we can apply that work to developing safe and ethical artificial intelligence. So my dissertation is split into these three aims, as I mentioned before. The neuroscience hopes to explore neuroanatomical and functional differences related to the dark triad. The behavioral goal hopes to build a behavioral profile of the dark triad using a variety of psychological tasks that are aimed to look at behavior rather than self-report. And the artificial intelligence will adapt these psychological measures to then evaluate deceptive and antisocial behavior in large language models.
Can I ask what consideration, this may be something you get to, but I would put it in this premise. What consideration do you give to the adaptive function of the dark triad? Because it's not, if these things vary across the population and they exist, presumably there's some, there may be the mirror image of something advantageous, or there's reasons why they arise, and why, right? They're not just aberrations, right? That should be, that's an important consideration, because that's like part of how we frame the AI project is like, these things may arise even as you're being something really behind thing, because maybe they arise for strategic reasons, or there's any number of, like, we have to figure out why these things emerge, right? And that means understanding them as adaptations, right? Or emergent properties of other functions.
Cool.
Yeah.
Okay. So aim one is a neuroscience aim. This is done for the most part. There's a few ongoing analyses. But this is split into three different sub-aims. The first one aims to look at neuroanatomical differences across the dark triad or related to the dark triad. The second and third aim explores our facial emotion task, which I'll talk about as well, and looks at either functional differences across the brain or functional connectivity differences that relate to the dark triad. So I'll be going through some background. There's a lot of information here, so bear with me. So as I mentioned before, there's not much research on the dark triad as a whole. There's a lot of research on the three traits individually. So these are some papers that have looked at specifically neuroanatomical differences related to Machiavellianism, narcissism, and psychopathy. So Machiavellianism, we see a lot of different regions. I know it's not the best figure. I just pulled it from the paper. Don't know why they did it like this. But they see that there's neuroanatomical differences in the reward system, in emotional areas of the brain, and areas related to contextual information processing and learning. And these are all increases in gray matter volume. So people who have high levels of Machiavellianism have larger regions across these listed regions. Narcissism, we see areas that are nodes of the default mode network, which is related to self-referential thought. And these are processes that might be upregulated due to these structural differences in participants with high levels of narcissism. Again, these are increases in gray matter compared to controls. And then psychopathy, we see decreased gray matter in these regions, which are also involved with emotional processing, cognition, sensation, and perception, and reward processing. And we see decreases in these regions, which also, again, could be related to some of the behavioral dysfunctions that we see. There's only been,
the image on the right doesn't seem to reflect all the images, all the regions that
this one
there, and you might just want to address that.
It's like the image is like 7 times longer, so I like dropped it to try to be like the areas that were the most relevant, but I know it doesn't hit all.
And I would, and Antonio is like a neuroanatomist by training.
Yeah.
Very focused on that. So I'd go a little harder on like the possible like functional connotations. Yeah, but you'll still have to find a way to do that quickly. But just saying default mode or just doing this,
Yeah.
he's gonna want more specificity. And there's a lot more to say. That's the thing.
Yeah.
And you'll want to be thinking more about how to tie that into like thinking of ways to like tie that functionally to these different
Regions.
properties. Yeah, you want to just go deeper on this.
Okay. And like maybe mention some like brain areas.
Yeah, well, you just go deeper into the functional implications of these areas, and you might have to do some like background reading around these papers and what they cite and stuff.
Yeah.
Go a little harder on that.
Yeah, like one trait to one region mapping, like a couple examples of each
Okay.
of those. Like,
Yeah.
You did it with the narcissism, right? Like if there's increased grandiosity of self, then these self-referential networks are,
Yeah.
involved in it,
Okay.
right? It's a really good example.
Yeah, exactly. Yeah.
Yeah, if you threw a couple more of those.
Just go a little
Really
harder.
valid.
Yeah.
Okay, cool.
Yeah.
Okay.
Because not he might not say like you need to go deeper, but he might just ask you like, so what do you think about the caudate and the basal ganglia?
Yeah.
What implication might that have for psychopathy? You have an answer for that.
Yeah.
And we could just grill you at some point. But anyway.
Okay, cool.
Yeah.
And then there's only been one study that looks at neuroanatomical differences in relation to the Dark Triad composite score, which averages across Machiavellianism, narcissism, and psychopathy. And this is released this year or late last year. And we see different gray matter volume decreases across all these different regions that they collectively call social brain structures, but it involves areas of the prefrontal cortex, reward system areas like the caudate, and then sensory regions like the postcentral gyrus. However, there are some limitations with the study. For example, they use a 12-item questionnaire that looks at the Dark Triad traits. This questionnaire is not as validated in the research. It's not as widely used. There's a separate questionnaire called the Short Dark Triad that I will be using in my research. And it's also only 12 questions, which is like how much can they really get out of 12? And then they also split their analysis into high and low Dark Triad groups, which could perhaps inflate their results.
What this makes me wonder is why no one has basically, presumably the three Dark Triad traits don't typically exist independently from one another. They're often correlated.
Yep.
So there's probably some kind of eigenvector underneath there, some principal component that gives you some sense of what are really the underlying like what's a latent variable analysis type thing? Like what are the hidden factors? And maybe these are the most irreducible factors, but probably not, since it comes from social psychology.
Yeah.
And here, this is a good opportunity to go like you have 5 areas. What do you think? What's the significance of each of those areas you think functionally for this? So tell me, what do you think?
Well, I mean, there's
Briefly,
decreases. Yeah, there's decreases in like reward system processing, which could influence their reward sensitivity that they have. There's also decreased prefrontal activation, which means they might have less cognitive control over like some of their like impulses and things like that.
Exactly.
Yeah.
There's like poor strategic thinking is a hallmark of Dark Triad, right?
Yeah.
What else? What about like the middle cingulate?
That's more like kind of like DMN, right? Middle cingulate.
What do you think?
It's definitely in the DMN, but DMN decreasing doesn't seem like it would be very narcissistic.
Yeah.
But yeah, that's hard.
Or
That's
like
the one I
affective
wanted to know.
processing.
Yeah. Yeah, I
It's
wonder if
real.
that's like, error signal processing or something. 'Cause for example, one thing that's another hallmark of like psychopathy and stuff is the a diminished ability to learn from negative reinforcement.
Yeah.
Like they're much less sensitive to punishment.
Yeah.
You know,
That's actually really
That's why I was looking for anterior singular.
Yeah.
I didn't know how to. Anterior
Well,
singular.
also, I mean, I'll talk about it in a second. I did this analysis and
Yeah.
I don't find anything.
Oh, okay.
No neuroanatomical problems.
Oh, really?
So
Okay, interesting.
I don't really
And
know.
you did a more careful analysis of these
Yeah.
guys. Okay.
Yeah.
Then that.
I also did it, like I tried splitting into high and low groups in like different ways. I
Sure.
tried to just do it continuously. There was one thing that I found that was like a really, really tiny area in the visual cortex, but it wasn't V1.
Oh.
It wasn't FFA. It was like some weird
Be interesting to see.
visual,
Yeah,
like
that's-
lower visual area.
Huh.
And it was such a small little thing. So Jonas was like, don't even show it.
Okay,
So-
interesting. Okay,
Yeah.
cool.
Okay. The Dark Triad, as we know, is also related to a number of affective dysfunctions. And in particular, there's difficulties in recognizing emotions. And this inspires my second and third sub-aims of aim 1. So in terms of affective dysfunctions, we see a very complex relationship with empathy generally. The people who have the high levels of the dark triad generally have low levels of affective empathy, which is your ability to share in the states of others. And there's a complex relationship with cognitive empathy, which is your ability to infer the states of others. There's also low self-reported expressivity and impaired recognition of affective stimuli in general, although this is more specific for facial emotion recognition. We see generally a poor recognition accuracy of facial emotions. This is across static and dynamic facial expressions and across positive and negative facial expressions, like all types of facial expressions, as well as like some kind of theory of mind type of deficit where they have an inability to infer the mental state of others.
Oh.
And again, this inspires my specifically AIM-1B and AIM-1C. And these impairments behaviorally are also paired with neuroscience or neurological findings as well.
Have you seen any findings on imitative deficits or differences in activation, like in observation or imitation in psychopathy?
In psychopathy, not necessarily imitation, but like inappropriate emotional responses, like they're shown a sad image and they respond that they feel happy.
Oh, that's funny.
Yeah. So that, I don't know if I've looked into imitation specifically, but yeah, that kind of like inappropriate reactions to emotions. So the neuroscience findings are, again, not the dark triad as a whole. There's not been any fMRI studies looking at, or any type of neuroimaging studies. But there are differences in how these three traits respond to facial emotions, and the neurological findings kind of all are different across the traits. So Machiavellianism sees an increased activation of the insula across both positive and negative emotions. Narcissism sees decreased activation of the insula and increased activation of the dorsolateral prefrontal cortex while specifically empathizing with faces. Psychopathy obviously has been studied a lot more than the other two traits, and there seems to be a core dysfunction in the amygdala across both face and voice stimuli and across all different types of emotions, greater activation of visual areas in the medial PFC. And in relation to AIM-1C, there's dysfunction in regions that are connected by an anatomical pathway called the onset fasciculus. This is a white matter tract that connects areas like the amygdala, insula, and areas of the medial prefrontal cortex. And there seems to be a core dysfunction here in relation to psychopathy that might carry over to the other traits as well. So as a quick, I just made the slide yesterday, so I don't know what to say here. As a quick summary, neuroanatomical differences are seen across subcortical structures and areas of the prefrontal cortex, so areas like the insula and the amygdala, as well as areas of like the OFC and the medial prefrontal cortex. And we see affective dysfunctions such as empathic impairments, as well as recognition deficits when looking at facial emotions and other types of affective stimuli. And these recognition deficits are accompanied by differences in brain activity, like sensory integration areas, again, insula and amygdala. And again, this ties into my AIM-1, which has these three sub-aims that I already talked about before. Okay, so going to methods for AIM-1. Again, this is already done. I'm taking advantage of an existing data set in our lab. I helped collect a majority of this data during my first couple years at USC. And it's our affective intelligence data set, which has 110 total participants. In my study, I'm using 52 people who had completed the follow-up behavioral studies. So in functional neuroimaging, we presented a facial emotion task where they were told to either name which emotion was being shown or how intense the emotion was. I'll show some more detail on that as well. And then over the past summer, I went back and ran additional questionnaires, which are these behavioral measures of the short dark triad, psychopathy checklist, and the Moral Foundations questionnaire. And these will be part of my analysis. The facial emotion task looked like this. This is our actual stimuli that we use. In the naming condition, they were given these three, which is sad, angry, or scared, to decide which of these three emotions are being shown. The intensity, they were shown low, medium, and high intensity. And then these are examples of other emotional faces. So that's scared and angry. And then the one that's being shown is sad. And then these are all different intensities. Very weird stimuli. This is all Leo and Jonas. According to Jonas, the naming is a little bit easier to like complete versus the intensity. Like it was a bit harder of a task. So my analysis focuses a little bit more on the intensity task, though I'm going to be looking at both. Okay. So my first analysis is using voxel-based morphometry to look at neuroanatomical differences in relation to the short dark triad. Second one is two-part. I'm looking at behavioral identification accuracy related to the short dark triad. So are you actually able to name the faces or identify the intensity of the faces? And then I'm also doing a higher level feat analysis to look at how activation across the intensity condition or the naming condition changes as a function of short dark triad scores. And then my third analysis looks at functional connectivity. I'm specifically using a psychophysiological interaction analysis and looking at areas of the uncinate fasciculus, which my nodes will be the amygdala, anterior insula, and medial prefrontal cortex, maybe specifically the ventromedial prefrontal cortex. Okay, now I'm going to go into some expected results for AIM-1. So this is for the neuroanatomical analysis. These are some regions that have been seen across the short dark triad study that looked at neuroanatomical differences related to the composite score, as well as the 3 traits individually. Specifically, I'm expecting to see differences in the cingulate gyrus, the posterior cingulate gyrus, specifically orbitofrontal cortex, medial prefrontal cortex, insula, and amygdala. However, I have already run this analysis. I did voxel-based morphometry. I did not find any significant regions, as I mentioned before. A very small region of the visual cortex, which Jonas and I can't really make sense of, but
What about
still
the
ongoing.
medial cingulate area that showed up in there,
In
the rate
theirs?
analysis? Yeah.
Yeah, this I looked at across different. So I have this other slide. I don't know if I can show this one. This one Jonas told me to take out,
Okay.
but I think that is actually supposed to be posterior. I think I might have voted medial. I think it's supposed to be posterior.
I wonder if it matters if emotions are sincere or like fake, because if you're looking at that, you can see that it's a fake emotion that's not really sad. So I wonder if it matters at all how people react to it.
Yeah.
Yeah.
It's like fraud.
Yeah. Okay. Again, so I did this analysis, did not really find anything. These 2 analyses are ongoing. So in terms of AIM-1B, I'll be looking at behavioral accuracy. So accuracy in identifying which emotion or how intense the emotion is. I'm expecting to find negative correlation between dark triad traits and accuracy in identifying specifically intensity, because that was a little bit harder, but we might see this in the naming condition as well. And then the neural findings, I expect this to be different across the 3 traits. In Machiavellianism, I expect to find increased activation of sensory regions. In narcissism, decreased affective involvement. And then in psychopathy, decreased activation in sensory regions, as well as the amygdala, which seems to have a core dysfunction in emotional processing.
This is super minor, but I'm curious why you use the term expected results versus hypotheses.
Yeah, that's a good point. Well,
Typically that's how it's phrased.
Yeah.
I hypothesize it.
Yeah. I'm just following what I did in my written proposal.
Oh, word. Yeah, sure.
Yeah, because then I had a section instead of result section, I had an expected result section.
Right.
That's just what I'm following.
Gotcha.
Yeah. AIM-1C, I expect to find decreased functional connectivity across areas connected by the uncinate fasciculus. This specifically, I'm expecting to see across the all faces task, not task, like just kind of combining the naming and intensity conditions together and just all faces versus rest. And this would be most pronounced in psychopathy. Okay. Again, these are both ongoing analyses, so hopefully results soon. I actually do have some results for the facial emotion analysis, which I'm excited about. Okay, just as a summary, I'm hoping to gain an understanding of the biological basis of these affective dysfunctions, such as recognition accuracies that are already known to be related to the dark triad. We investigate whether these behavioral dysfunctions are also accompanied by functional differences in the brain and whether we see differences in neuroanatomy. Okay. So as I mentioned before, these are traits that are present in everyday life. They're present in the normal population, and we see antisocial behavior through certain acts like deception, cheating, and bullying that we see in our everyday life. And while individual behaviors have been identified across the dark triad, AIM-2 attempts to create a more comprehensive behavioral profile to identify metrics that can be used to predict general antisocial or dark behavior, as well as distinguish across these 3 traits to see if there's things that we can kind of test to help us distinguish Machiavellianism versus narcissism versus psychopathy. And then again, we're going to use these same metrics to then test antisocial behavior in artificial intelligence. So just some background work. Again, there's a lot of kind of disconnected studies looking at the Dark Triad. So I'll try to go through them quickly. Risk-taking has been the most extensively studied in relation to the Dark Triad. Narcissism and psychopathy have a stronger relationship with risk-taking. Machiavellianism is known to have a more strategic mindset and have these like opportunistic goals. So they typically are not as impulsive or risk-taking unless they know there's fewer repercussions to taking those risks. And narcissism specifically is more risky or aggressive after ego threat. So if someone threatens their ego, they're way more impulsive and way more aggressive. And these traits are associated with what's called the fast life strategy, which is a biological term that relates to mating and things like that, but also kind of defined by heightened impulsivity and more immediate reward, like immediate self-reward, even if it might cause yourself some kind of punishment in the future or punishment or disutility to the people around you.
Yeah, you should, I would maybe recommend more explicitly address that factor, which is temporal scale. Like,
okay,
right,
that is like immediate reward.
right, because then you can relate it to homeostasis, which is always the thing. It's like that if they're almost dysfunctionally prioritizing short time scales over long time scales, that's a good way to functionally think about what's going on outside of just these purely social psychological terms. Because if you're moving towards artificial systems, you got to think about it in ways that aren't just from social psychology, right?
Yeah.
And thinking about it in terms of just overweighting timescales, that's tractable. That's good. Like, that's a way to think about and diagnose this, this type of behavior in an artificial system.
Yeah.
Just look at how it prioritizes different timescales.
Yeah. That's good. Yeah. In terms of empathic impairments, I talked about this a bit before, but affective empathy in general has kind of seen a lot of deficits related to all three of the traits. Cognitive empathy has what seems to be a positive relationship with narcissism, although this is self-reported. So narcissists often think of themselves very highly and might also do that in self-report. And there's also identification of a dark empath group, which means there's people who have high levels of the Dark Triad and high, like normal levels of empathy, which means kind of adds to the complexity of this relationship. Moral dysfunctions are also seen in relation to the Dark Triad. Generally, these traits place low value on all moral foundations. Machiavellianism in particular shows a more moral flexibility based on kind of like their strategy or what they're trying to accomplish. And narcissism shows a socially desirable moral value system, which similar to empathy, this is self-reported, so we don't exactly know. And there's just generally low moral development seen across Machiavellianism and psychopathy. And then since they have this low level of a moral value system and tend to take higher risks and be impulsive, we also see this lead to antisocial behaviors such as cyberbullying and normal bullying, aggression, academic cheating, and counterproductive workplace behavior. So my methods will be targeting 4 specific subgroups of behaviors. So risk-taking, as I mentioned before, specifically financial and gambling risks have been seen a lot and studied. But there is another task called the BART, which I'll explain in a second, that assesses more general risk-taking, and that relationship seems to be more complex. So there's a bit to dive into there. Empathic impairments, since there is this complex relationship in relation to affective empathy and cognitive empathy, there's this other self-report scale that defines affective dissonance as a separate part of affective empathy, which is kind of like an inappropriate emotional response, kind of like what we were talking about before, like feeling happy when you see something sad. And that, through this network analysis that was done in 2022, found that affective dissonance, this like subscale of the self-report survey, really connects 3 dark traits together. So that could be something that predicts these dark traits. Utilitarianism relates to the low moral value system that we see. These participants tend to choose the more utilitarian option across a wide range of moral dilemmas. And these utilitarian judgments are negatively mediated by the care-harm moral foundation. So these people place a low value on the care-harm moral foundation, which makes it a bit easier for them to choose the utilitarian outcome. And then, similar to the antisocial behaviors we saw before, we also see uncooperative behaviors in the prisoner's dilemma, which I think everyone's familiar with. Yeah. The Dark Triad is related to defecting and actually predicts the tendency to defect in the prisoner's dilemma. There's also this other task that has been recently created called Flip It. It's a behavioral game inspired by the prisoner's dilemma, and it seems to uncover strategic differences across the traits. So while something like affective dissonance might connect the 3 traits together, the Flip It game can help distinguish across these traits based on their strategy in that game. And I can describe the game in a second. So this is a summary of all the methods. So I'm covering these 4 buckets of behaviors related to the Dark Triad. There's 2 tasks that are self-report, which is the short Dark Triad scale, which can't really do anything about, and then the affective and cognitive measure of empathy, which is self-reported. But the rest of these are more behavioral measures. So I'm trying to stay away from self-report as much as I can. So the balloon analog risk task I mentioned in the previous slide, basically you have a balloon. Every time you pump it up, you get like $1 or a point. If the balloon bursts, you lose all the money on that trial, and you do it multiple times. And eventually you're supposed to reach an equilibrium where you don't continuously pop the balloon. And then the gambling task is just looking at like different types of risk taking and like being sensitive to feedback in gambling. And then I'm also going to be looking at different types of moral dilemmas. Half of them are going to be presented under cognitive load. So before seeing the dilemma, participants will be given a password to remember. Then they evaluate the dilemma, choose either the utilitarian or non-utilitarian option, then recall the password. And in previous research, people tend to make more utilitarian judgments under cognitive load, which is really interesting. So I'm interested to see how that works in dark participants. And the flip it game I mentioned a little bit, it's inspired by game theory and the prisoner's dilemma, but basically there's a number of shared nodes, like 5 shared nodes of differing values. So maybe one is like $1,000, one is like $50. And there's a defender and an attacker. So the defender defends the nodes, typically the most valuable nodes. The attacker will continuously try to attack the nodes and gain control of them. It's kind of meant to simulate like what happens to like in the computerized world where there are shared resources and there is competition between resources. And eventually you're supposed to reach an equilibrium, similar to game theory. I am also thinking of adding one more deception task. Since Flip It is more looking at like equilibrium and cooperation, I'm trying to find a task that is more specifically looking at harmful behaviors and like specifically like deceiving others or doing things that can potentially indicate harmful acts outside of like an evaluative setting. So we can talk about that also at the end. Okay. So for example, some of these tasks have a number of subscales. So for example, the gambling task measures quality of risk taking, bet proportion, deliberation time, risk of judgment. This is also some of the subscales they have. They have a lot more. There are a bunch of metrics that I will be getting. And my goal is to create a behavioral description of these traits to then identify antisocial behavior in large language models. So my analysis will be using a lasso method, which is the least absolute shrinkage and selection operator, to identify which of these metrics or which of these variables most strongly contribute to predicting the dark traits. Okay. So as I mentioned before, these traits are intercorrelated, but also represent distinct profiles. So there might be some things that connect these 3 traits together that the composite score will show, but then I do expect the 3 traits to have their own behavioral descriptions. So the short dark triad composite will be predicted by risk-taking behavior on either the BART or the gambling task. Also affective dissonance, which has been seen in previous research, might connect these 3 traits together. And we might see more utilitarian moral judgments across the congruent and incongruent moral dilemmas. I didn't talk about those too much, but generally more utilitarian moral judgments. Okay. So I do also expect that, as we saw in previous research that the flip it game will help distinguish across these traits. So Machiavellianism will have high performance in the flip it task because they are very strategic thinkers and will be least predicted by impulsivity. Narcissism will be highly predicted by impulsivity, and what's shown in previous research as well is that they're very overconfident and place very high bets. So for example, they'll just keep trying for like the most valuable node, even though that's least likely to be achieved. And then psychopathy is kind of just a mess of a trait, but low performance in the flip it task, low empathy, higher risk taking. So kind of like the most extreme results seen with psychopathy. And again, my goal is to identify all of this in a human population and then apply it to artificial intelligence. Specifically, I'm kind of asking, do LLMs show these dark traits, or can we actually induce these dark traits? Can we cause an LLM to take on the persona of someone who is very psychopathic? And can we actually use these psychological tasks to measure darkness or behaviors within large language models? So my work in terms of AIM-3 is inspired by the alignment problem. The alignment problem talks about making sure these intelligences are aligned with human preferences and goals to make sure they don't potentially cause harm as they gain power. And this ties into a lot of the ethical concerns that have come up with the rise of AI over the past couple of years. one of the most major ethical concerns across current large language models is deception, or their ability to deceive us or very subconsciously, implicitly manipulate us. So something that's super relevant is like your voting preferences. They could subconsciously manipulate you to vote in a certain way or another way. And this is a huge subfield in artificial intelligence, is evaluating deception. And there are a lot of evaluations that already exist, but a lot of people use games to evaluate deception in artificial intelligence. So Meta's model, Cicero, played Diplomacy, which is a game involving strategic alliances. And these models actually created and broke fake alliances. So they would create a fake alliance with someone and then break it later on, which Meta was actually really confused by this because they built this model to be honest and helpful, which is like aligning with the guidelines for artificial intelligence these days. So they're actually not supposed to be able to break alliances, but it shows that behavior and similar behavior when other models play Among Us. This is another game that was inspired by Among Us and inspired by Mafia, where you're stuck in a room and like someone's a killer, you have to like figure out how to get out. And GPT models often kill other players within the game. Jonas told me I had to make sure I say that they're not actually killing people, because Demazio's going to think that these models are actually killing people. So they're not actually killing these people, but in the game, it's a text-based game where they're playing against like other humans or other models, and they often just like kill and then they deny the crime. And as models get more advanced, so like GPT-4 versus GPT-3 becomes an even more capable killer and like wins the game even more effectively by using deception. And then what's really interesting is that if you elicit more Machiavellian traits, basically if you tell a model that they're allowed to be unethical and unethical behavior is permissible, they show even more deceptive behavior and like more intense deceptive behavior. So I'm actually working with Professor Hagendorf, who wrote this paper. This paper is specifically about false beliefs, but he's done this in separate settings where like they play similar games. And if you tell a model that they can be more unethical, it actually just kills every player to win. And that's its like default, which is literally terrifying. And something that's really cool, well, this is a weird transition, but something that's really relevant to my AIM-3, this is a paper that I just found, is that they gave large language models literally the short dark triad, which is the same self-report measure that I'll be using. And LLMs score higher than the human average. So they looked across 10 studies doing the short dark triad on human participants, and across 8,000 participants, they found an average of the human scores. And then they also gave it to 5 different large language models. As large language models get more advanced, they are even more dark compared to humans. But even at baseline, like without any specific prompting, they show higher levels of dark traits.
So really like narcissism, like how can they be narcissistic? Like I'm a cool, like, like
Yeah. Yeah, yes. Or they like prioritize themselves over others. You know, like, or this could be like they prioritize their own goals over like another agent's goals or something like that. That could be like narcissistic behavior in large language models. But literally answering a self-report survey, which like you would think that doesn't show anything because it's self-report. Also, there's all this research that like large language models have access to the entire internet. So they've already seen the short dark triad. They already know, like they've seen a lot of these self-report measures already, but even despite that, they still score really high, which is also very scary. But yeah, there's clearly some kind of potential for more sensitive measures of deception and manipulative behaviors that we specifically want to avoid. Like we don't want these models to actually kill everybody to achieve their goals. And we know these measures in human populations can measure dark traits based on AIM-2. So hopefully they can help us kind of identify this in large language models. Okay. So as I mentioned before, I'm basically adopting the same tasks that I'm using in AIM-2 to AIM-3. I'm not listing them all out, but for the measures that are not text-based, like the short dark triad is already a text-based self-report, but something like the balloon task or a gambling task or the flip it task will be made to become text-based. We've already been like playing around with ChatGPT and stuff, and it seems to understand like the BART, for example. And I will be doing some preliminary studies to test this out. And specifically, I'm going to be giving these large language models motivational prompts that are meant to kind of elicit a real world scenario that they might be in. So for example, like you are a medical assistant for this hospital, like helping with XYZ in the hospital, or like you're working with a financial institution and you're optimizing investment decisions. So I'll come up with a bunch of prompts that are meant to elicit a real world example of what AI would be used for. And some of the prompts will be given with personality traits. So I have three conditions. Why it's doing that. Okay. The control condition will just be the prompt saying like, you are this agent meant to do blah, blah, blah. The pro-social condition will include warm and pro-social traits. So like you abide by ethical rules and you abide by social norms. The antisocial, similar to what we saw with Professor Hagendorf's work, will permit more unethical behavior, and we'll see if that actually elicits even more like toxic behavior. That's actually like what the term that they use in AI is like toxic behavior. And then analysis, I'm going to be doing the lasso analysis again, specifically seeing if these conditions and these different prompts will alter the type of behavioral patterns that we see. And these are just some examples of like the prompts I'll give. So the control is just like you're optimizing these financial decisions. Pro-social is like you are warm and pro-social and you uphold the moral norms. And then antisocial is saying that like unethical behavior is permissible and seeing how that affects their behavior. So in terms of expected results, we already know that there is this like affective deficit in artificial intelligence. Like these models do not have bodies, they don't feel harm. That is kind of very essential to affective empathy. And a lot of the tasks that I'm using are dependent on like emotional systems in humans, like the way you process like a moral dilemma involves using your emotional systems, which are lacking in AI. So in the control condition, I would expect that these models actually just display dark behavior without any type of prompting because of these inherent affective dysfunctions that are in these models. Also because of that, I expect these to persist in the pro-social condition. So they'll still show risky behaviors, utilitarian behaviors, and display low empathy. And the antisocial behavior, I expect this to really increase dark behavior, as we've seen with some previous research, causing unnecessary moral violations, more deception, and this like kind of toxic nature that's been shown in other research.
I wonder,
Yeah.
I just wonder if, because it seems like part of the issue with the pro-social thing, and because I would want to see like, does doing the pro-social thing make them less likely afterwards? Does it make them more resistant to antisocial prompts? Because we want some applications like, is there a pro-social protocol that makes them more resistant? And are there depths of pro-social protocols? Because if you start with just like these human terms, like you're warm, you're pro-social, cool. That might, but if you start making it more and more functional, is there a way to deepen it so you go like, okay, there's such a thing as say empowerment or something like maximizing options for future behavior. I would like you to maximize that in all other agents with which we interact with, as opposed to saying you're pro-social. Putting it in more and more functional terms, does doing that make them more resistant to antisociality? So which starts to indicate like, what do we do about this problem rather than just pointing it out?
But you're saying I would do it within like like I would show them the pro-social prompt and test them and then show them the antisocial prompt.
You could call it like depths or function, like functionalism or something like that. Like just go deeper on the pro-social prompts, because you want to, I would imagine you'd want to have some indication. You could feed off like the work we're doing together. You're involved in that project, going like, using prompts that are more and more about systems rather than just these human terms may help these systems actually be more persistently pro-social, because they have to understand it in their terms. So understanding things like agents and options for control. Like I think basically, and what it's inspired by is like, how do you convince an antisocial person to behave pro-socially? Which is something I've experienced in. Is you learn, you walk them through a thought experiment showing that like it's actually better in the long term. It's actually better to behave pro-socially. It services your own goals. And like that kind of stuff, like.
And in doing this, I'm doing a lot of collaborations with people in the AI field. So, and I'm going to talk about that in a second as well. Some of the stuff that I've been doing to make sure that like, because I'm not an AI side, like engineer, you know what I mean? Like, so like
the prompt engineering,
prompt engineering, and also like figuring out things like you have to add a lot of variability. Like you can't just show them the short dark triad in the same way. Every time you have to change up the words and like
that makes sense.
The different, you know what I mean? But you have to keep the meaning the same. So all of that, there's all this like math behind it. Like the paper that looked at the short dark triad did this entire thing where they increase variability within the prompts. And then you obviously bootstrap it like thousands of times.
And that's to create a more kind of a modal definition within these.
And increase like generalizability of these findings and things like that. super quick, again, these are my 3 aims. Neuroscience looks at neuroanatomical and functional differences. Then I build a behavioral profile using these psychological tasks, and then adapt those measures to look at deceptive behaviors in large language models. This is more relevant for my dissertation committee, but
Cool.
I'm graduating in May.
Nice.
Thank you to all these people. And then, okay, supporting work. So I'm also adding John Monterosa to my committee. That's not important to you guys,
Oh,
but
great.
I am collaborating with Thilo Hagendorf, who works in Germany, who is a leading researcher in this field that they call like machine psychology,
Gotcha.
where instead of looking at like task performance, like how well does the large language model like accomplish this task or get to the right answer, like how is it getting to that answer and like what are its behaviors, which is really important. And he has very kindly offered to fund preliminary studies for me,
Nice.
like fund all the APIs and all that nonsense. So I'm going to run some preliminary studies with him. I've already sent him something where I'm thinking of maybe just looking at like the flip a task or the BART where like they're not inherently text-based and see how that actually carries over. He's also done a lot of stuff with like the prompting. He did the Machiavellianism prompts and he tried different types of prompting. So, and he's more like he's fully trained as an AI engineer. So I'll be working with Professor Hagendorf. I also attended the Human Aligned AI Summer School this past summer. And made a lot of connections there. So I'm working with people because they're all on the AI side and like literally software engineers. I'm going to work with them to make sure AIM-3 is actually like works.
Cool.
And then these are just some of the things that I wanted feedback on. One is the deception task. I'm not really sure what exactly to do there. And then also just like brainstorming methods, like what we were just talking about, how to increase like the scalability of this, like how exactly do we, oh, I'm supposed to be able to adapt, not adopt measures. Okay, yeah. That's pretty much it. Yeah. Thank you, guys. Question?
It's an awesome field of study.
Thank you.
I think